What is the problem with the theoretical prediction of the blackbody's behavior as its temperature increases? A. It predicts that the intensity of the emitted light does not change as the wavelength decreases. B. The intensity approaches zero as the wavelength increases. C. The intensity of the emitted light approaches zero as the wavelength decreases. And D. It predicts that the intensity of the emitted light becomes infinite as the wavelength decreases. The kind of code name for this is called the ultraviolet explosion, which means as the wavelength is decreasing, the intensity becomes infinite or explodes. That's the colloquial term for it. So the answer here would be D. However, can you see a really big problem with the classical theory prediction? Again, that's over here, this curve at 5,000 K, and here's the measured data at 5,000 K. So, and of course, green and red were also measured. This is 3,000 K, this is 4,000 K, but this is the one that would correspond here. So I think I've already given the hint. What's wrong with the theory? The classical theory shows that the intensity of the emitted radiation, that's this curve here, you can see that it's coming off the chart here, and you can imagine it just keeps on going, and you don't have to imagine, that's actually what the theory says. So it's approaching infinity as the wavelength gets shorter, which is not at all what happens. You can see that the intensity of the higher frequency, the lower wavelength light, it does increase, and you can see it moving to the left, but it gets to a peak, and then instead of continuing on to infinity, it comes down. Okay, so shorter wavelengths means the light is moving into the ultraviolet end of the spectrum. Hence, a quite dramatic name was put on this. It was called the ultraviolet catastrophe.